Okay, I want to do a few problems from section 7.1. First one I want to do is number 17, which is talking about births of boys. And I'm going to paraphrase. There's the claim that for boys, the real proportion is 0.512, a little over 50%. Okay, this study sample 186 births, randomly, simple random sample, yes or no. This is binomial, it checks all the marks. The number of boys is X, which is 426. So, the sample proportion, 426 over 860 is 0.495. Okay, we want to test the claim with a 95% confidence interval. So, I'm going to draw my diagram. I'm out here, I need my Z alpha over 2 or my critical Z. 95%, I know this tail is 0.025, this tail is 0.025, the area in here is 0.95. Did this in the other video. 95% confidence interval, the Z is 1.96. You can look that up in the table right here as well, which is at the bottom of the positive Z scores. So, now all I need to do is find my margin of error. It's 1.96. The square root of p hat times q hat, which in this case is 0.505, divided by n, which is 860. My margin of error, 0.0334. I need some space here. So I'm going to finish it off. I'm going to take p hat, subtract the margin of error is less than p hat plus the margin of error. So subtract 0.0334, add it, and our 95% confidence interval, 0.462 is less than p, it's less than 0.528. Okay, here's how we finish our analysis. The 0.512 actually could lie in here, so therefore failed to reject the claim. Notice I didn't say we proved it, we just couldn't reject it. Failing to reject is not very strong. We actually try and set up experiments and such so that we do reject something, but in this case we can't say much. Failed to reject, insufficient evidence. The true value of p could be in our confidence interval. So, that's a confidence interval one. I'm going to do number 19 as well. It's an accurate order claim of Burger King. So the Burger King study found, let's see, 264 orders were accurate. I guess that should be a U. And 54 not accurate. What we want to find is a 99% confidence interval of the not accurate orders. So I need a new Z alpha over 2. This is 0.005. This tail is 0.005. In between is 0.99. And if we look this up, we have a Z of 2.575. Okay, so I need my p-hat. Now be careful here. 54 were not accurate, but don't forget to add those two together to get your N. Which is 318. My p-hat is 0.170. Just like before, I'm now going to find my margin of error. 2.575 square root 0.17 times 0.83 over 318. 0.054. So, p hat subtract e is less than p is less than p hat plus e. So I've got 0.116 is less than P, is less than 0.224. Problem wanted it in percents. So I change it to that. So it looks like we are now 99% confident that the true value of inaccurate orders from Burger King lies between 11.6 and 22.4%. Now the other part of this says, let's compare this to Wendy's. And let's see if I can do this without messing this up. Okay, so this is Burger King. Wendy's was 6.2%. Was less than P, was less than 15.9%. What can we say? Well, it looks like Wendy's would be lower. But the problem is these things overlay. So it could be that maybe the true percentage of Wendy's was here, near 15.9. Well, that fits in here as well. So Wendy's confidence interval looks like this, Burger King like this. Well, the true P could be in there, and so we can't really say that Wendy's is less than Burger King or less accurate. Okay, one more problem. I want to do a sample size. If I can find a decent sample size. Maybe I'll save that for another video.